What is the vertex of the following graph? This is an overly simple question. You have to first think about this formula. Because this equation is in vertex form. This is the equation for vertex form. Alright? The vertex is HK. So basically we need to know what H and K are. Since there's a minus right here, that means the opposite of whatever number is right here. Since there's a plus right here, that means just take that number. So simply, the vertex, actually let's start over, H, well, the opposite of this number right here. So what's the opposite of negative 3? 3. And K, well, that's just, K is a number, plus, so it's 1. So my vertex is 3, 1. It's probably one of the easiest problems you'll get. All you got to do is look at it, opposite of this, that number, vertex. Bam. Pretty cool. Okay. Now, the second one, describe the parabola formed by the following function in terms of, is it facing up or is it facing down? Is it wide or is it narrow? Now, do we care about the vertex for that? No. The vertex is kind of where the parabola is located. What we care about is your A value. The A value in front, remember that little guy, A value? A value is the number in front. So in this situation, what's A? A is a number right there, so that is -9. So what does that mean? Well, let's make a little legend to help us so that we can reference it later. If A is greater than 0, or other words means positive, what do we know about it? Meaning it's positive. What does a positive A value mean? It is happy, which means it's up. Looks like a U, up. If A is less than 0, which means it's negative, what's that mean? It's sad, it's frowning, it's down. I don't mind you putting a up or down parabola. You don't have to write the word up or down. You could just draw it. It's good enough for me. So negatives are sad, positives are happy. That's the first piece. So in this situation, if A is -9, what's the answer for this one? This one in particular, it's going to be -9 means it's sad. So our graph is going to be sad. Okay, next part. We got to talk about wide and narrow. If the absolute value of A, meaning ignore the negative, do you understand? Absolute value basically means whatever the value is, focus on the number and not if it's negative or positive. That's the basic idea of that. Now, if it is less than 1, it's either wide or narrow. If the absolute value of A is greater than 1, it's either wide or narrow. So, so if it's smaller than 1, which one is it? If it's smaller than 1, it is, anybody remember?
Wide.
If A, or the absolute value of A is less than 1, it is actually wide. If it's greater than 1, it's narrow. Now, what is it if it is equal to 1? It's normal. If you were to say something is wide or something is narrow, you have to have a normal. Normal is 1, so less than 1 is wide, greater than 1 is narrow. So in this situation, what's the absolute value of -9? 9. Is 9 greater or less than 1? It's greater than 1, so this is going to be narrow. So this particular problem, it's down and narrow. Again, the absolute values mean focus on the number, not if it's positive or negative. Here, you focus on the positive or negative to see if it's happy or sad. By the way, what's the vertex for this one? The vertex is -3, 2. You don't need to know it, it's just good to look at. Okay, the last one I haven't talked about, but you need to learn this one. Describe the translation of the graph blank to the graph blank. Translation means basically describe the movement. For instance, are the A values the same on these graphs? Both these graphs, the A value is 1, so it means it's normal and happy. Positive 1, so they're both normal and happy. So we don't even care about the A value. What we want to focus on are the vertex. If we were to make a very quick sketch of these two graphs, what would be this vertex for the first one? The first one, the vertex is 2, 3. Meaning we go over 2 and up 3. That's the first equation. The second equation, what's the vertex? The opposite of 1 is -1, and that is just -2. So the second one is over 1 to the left and down 2. There's my second equation. Now, do you understand you basically have a parabola at each of these? Is that okay? We don't care about the exact shape of the parabola. We just want to see how this parabola, it's the same shape at both graphs. How did we move from this first point to the second point? How did this graph move? How far over did it go? How far down did it go? And you have to describe the movement. The translation means the movement of the graph. So basically all we're going to do is go, okay, first of all, how far left did I go? You don't even worry about negative and positives. First of all, do you go left or right? Left. And you went 1, 2, 3. So you went left 3. Now, if we were starting at the second dot and went to the first, do you understand it'd be right 3? It all depends on, you might want to reference your first and second equation. If you don't, people all the time go backwards. They go from the second to the first. Here's where you're starting. You're going left 3, and then what are you doing? You're going down how far?
5.
Down 5? Is that right? That's it. Okay. You make a little sketch and you think about the coordinates and you go, okay, how far left or right did I go? How far up or down did I go? And you always got to go from the first to the second. Do not go from the second to the first. It helps to make a quick little dot sketch. You don't even have to draw the parabolas. You just got to put the dots down and see how did you get from one dot to the other. Because both these parabolas are identical looking. They are just, the vertices are different. So again, this particular answer moved left 3 and down 5. Now could I say down 5 and left 3? Yes. I'm not asking like slope one over the other. It just describes both characteristics of movement.